My name is Chris Gleason. I teach at Green Hill School in Ann Arbor, Michigan. I've been teaching for 27 years. Initially, I was teaching high school and at the community college level, and currently I'm teaching in 7th and 8th grade middle school science, and I'm a team leader. The goals for this particular activity with Model It is, first of all, to have practice again in a software program that allows students to design models instead of giving them prompts in what to do. So as you notice, they start off with a blank screen, and they have to place in the objects, and they have to assign variables. And the reason they were able to get those meters up there with the relationships that they drew is because they have to set up what the parameters are as relationships between those variables. Does something increase? Does something decrease? Does something stay the same? So by the time they create this model, it's only as good as the time they took to make sure that along the way the planning and the graphs were all made so that they made sense. When students present their models, and all of them have to present their models, then what we do is we look at what are the different variables, that the indirect and direct variables, and how they worked. They gain feedback from students. Okay? Sometimes what we'll do is we'll have students peer edit one another as to what they saw in this model, what could be different, you know, what would be better, what didn't work, did you really intend for this to happen, so that they help one another create the better model before they present this model. So we have student feedback, you know, we look at the presentation, and then we look at, you know, just the overall, did everything work? You know, so we have a rubric for Model It as to how we would give the kids feedback on it. Students are introduced to a lot of programs on the computer. They play games, they learn to, you know, troubleshoot. They actually, based on how they learned to beat or reach the highest level in a particular game, they do that all the time, but rarely are they introduced to a program on the computer that's educational software where students design their own models. And so Model It is a program and an opportunity for them to be able to do that. And you have to give them very little instruction, and all you need to do is give a little bit, tell them what it is you're looking for to be included in this, and then they take off on their own. And so it fits in as an opportunity, number one, for them to take everything they've learned, and now instead of on a test format or in a post-concept map, for them to design that, to design a model that will then show us their information. They're reenacting this activity. We had weather, because we do different units throughout the 8th grade. They did weather in September. And the reason we picked the fall for weather is because it's the most volatile time as the weather's transitioning from summer to winter. So there's a lot of changes, and as one of the students said today, the Earth is trying to maintain an equilibrium, a calm. To design their initial model usually takes about one class period, you know, before we dive into any kind of content. They are with their partners to brainstorm certain components of weather, okay? And then, you know, they're trying to see what the relationships might be. And sometimes, you know, they have a right relationship, and most of the time they don't. Our students are required to learn how to search for information, but not only do they search for information, but they have to know what information is most important for the question that they're researching. So by taking them through the process, we really believe very strongly that in our middle school science program and in our middle school in general, that we teach process to the students. So they know with all the information that's out there, they don't have to memorize a ton of information because they can get it if they know where to look for it, and then how to sort through it and take what's most important for them. So we hope to teach that to them. Our current students, as you might guess, they're wonderful. They're risk takers, and because they're risk takers, they allow us to provide them with many opportunities for them to explore what they can in order to be in charge of the learning. they're not just given carte blanche, but with some direction. They can answer their own questions that they have. They're encouraged to ask questions. They're encouraged to find answers. And as they do, to share them with all of us so that we can all learn. Our kids are bright. They're engaging. They're curious. And all those things drive our curriculum. One of the things that we really like about our program is that it does help the students learn critical thinking skills. That's very important to us. We also stress collaboration. How do you learn to work with one another? Today, if you go out into the workplace, people are working together with one another. Not one person is doing one part and one person is doing another part, and then you put the things together and hopefully you come out with a whole. Because not everybody has all the information at their fingertips. Students also engage in problem solving. As we mentioned earlier, if there was a problem with the probe, students were able to see this doesn't make sense, so I'm not going to continue with my experiment. We need to solve this problem first, and then we continue.